Welcome to our, I believe, 5th meeting of the National Collaboration on Bicycle, Pedestrian, and Accessibility Infrastructure Data. Thanks for joining us again. I will turn it over to Jeff Whitfield, who is one of our co-chairs.
Yeah, thank you, Justyna. Just wanted to echo that and say thank you again for taking some time out of your busy schedule for this important initiative. I just want to echo that welcome and say hello on behalf of the co-chairs. So thanks again for your time.
Thanks, Jeff. Go to the next slide, please. If you've attended our meetings before, you've seen our faces and names before, but just as a quick reminder, we have Anat, Daniel, and Jeff as our newly elected co-chairs. And on the Bureau of Transportation Statistics side, we have myself, Grace, Cyrus, and Jay with us today. A couple housekeeping notes. As usual, we are recording the meeting and the recording's already in progress. We ask you that you please stay muted. And then if you would like to ask a question, please raise your hand, or you're always welcome to type your question in the chat. We will be monitoring it throughout. And we also ask that you please type your affiliation in the chat. As in past meetings, we will share the slides, recording, and notes on GitHub about a week after our meeting. So for today's agenda, we will recap a couple of things from last time. We'll go over some of our meeting objectives for today. There are some status updates that we'd like to share with you. And if there are any community announcements, we'll open the floor for those. Majority of our time today will be spent in breakout rooms, doing a little bit of a discussion around data types and how they connect to our use cases. Next slide, please. So if you've attended our meetings before, you've seen the slide. We keep coming back to it because each time we have new attendees, and today we're actually part of the OpenThePaths conference at University of Washington. So we'll go over this again. So why are we here? It's because this group wants to advance the state of comprehensive, interoperable, and routable data on bike, ped, and physical accessibility infrastructure. And we want to do that through advancing open data standards. We also recognize that this is not something we can do alone. And then why is BTS your facilitator for this effort? We are specifically interested in facilitating this conversation because our long-term goal is to create geospatial data layers for bike, pedestrian, and accessibility infrastructure. And we think that improving data governance and coordination is a way of working towards that. We're also organizing this effort because we are the lead for FGDC's transportation subcommittee that is charged with coordinating geospatial transportation data community to promote best practices and develop standards to improve data quality, accessibility, exchange, and interoperability. As I already mentioned at the last meeting, we announced our newly elected co-chairs, and we also worked a bit in breakout rooms to start building a use case catalog for the kinds of data that we're interested in. So for today's meeting, next slide, please. We'll provide you a quick status update on the work that we've completed and the work that's in progress, and we'll move on to understanding data representations for modeling bike, pedestrian, and accessibility infrastructure. Cyrus, do you have a question?
Yep, sorry to interrupt.
No worries.
But just to make sure that we're connected to the folks in the room at University of Washington. Justyna, if you want to keep going, we
okay.
get this figured out in the back.
Sounds good. Next slide, please. Oh, actually, before we move on, this is a good stopping point to ask if there are any questions before we move on to our next update. David, we heard you for a second with some static.
Hello, we are here.
Hi, Anat.
Hi. There are probably 40 people in the room with me who are listening in today.
Awesome.
So good to see everyone.
Great to have
we'll
you.
try to stay quiet because I would imagine my mic is quite loud.
All right, awesome. Thanks so much for joining. All right. Are there any questions before I move on to the next slide? All right, hearing none, we will keep going. So last month we shared a version of our updated purpose and scope, and we had a deadline of April 5th for any comments that the community might want to contribute. We did not receive further comments, and we received 2 thumbs up. Thank you for that. We ended up merging that new purpose and scope into the collaboration framework document. This is now our official purpose and scope, and if in the future you think that they need to be revised or edited, you can create an issue to bring up the discussion or create a pull request if you have a suggestion for how we should change it. Next slide, please. Also last month, we broke out into groups and discussed use cases for bike ped and accessibility data. We ended up cleaning up that document and posting it, and we'll provide the link for that. As we get into more discussions, we really want this to be a resource that you continue to draw from, but also continue to contribute to. And we discussed some use cases, but we recognized that we probably didn't capture them all. Also, some of them might need some elaboration. So we would really appreciate if before the next meeting you reviewed the document, and if your organization's use case is not represented in it, or it's not as detailed as you would like it to be, we would love it for you to spend about 30 minutes editing that. And then what's coming up today is, another update before we move on to what's coming up today. So now that we have the purpose and scope formalized and the co-chairs elected, we'll be working on the final pieces to adopt the collaboration framework, which is a requirement of all FGDC working groups. This includes reproposing and agreeing to a decision-making procedure, deciding what our overall goals and objectives will be and figuring out the timeline for those, also identifying a subgroup structure to meet those goals and objectives. So we'll continue to ask for your input to make these things happen, and we'll do our best to balance the bureaucratic steps that we're required to take, but also more of the action-oriented content. All right. I would like to open it up to our community for any announcements you might have. Tinja, go ahead.
Turn on my mic, then I'm going to turn on my camera. And hi to all of you. And this is I am Tinja Tang, and I'm the division chief for the travel monitoring and service section in Federal Highways Office of Highway Policy Information. You know, as Justyna just said, you know, and we're going to do something practical here in the highway section here, and rubber meets the road, right? And on June 11th, we are going to do a special talking traffic webinar, and which we're going to cover the update to our 2016 micromobility data. And we did major changes, but do not worry about it. We'll make it much simpler than it used to be, you know. And we learned from our experience in working with state DOTs and local agencies, you know, for this completeness is great, but in order to have completeness, a data at, so complete, it prohibits a lot of agencies to send in data, to collect the data. So, but nevertheless, on June 11th, we're going to do this special talking traffic webinar. I'm going to post this announcement here. All of you on this webinar today, you're going to receive our invite for that special webinar. And we would love to hear from your comments, your input, before we kind of officially adopt it. So that's all I have. Next thing here, I'm going to copy and paste my announcement to the chat area. So thank you so much.
Thanks so much, Tinja. And thanks for pasting the link in the chat for the webinar. Appreciate that. Anything else? Jay, go ahead.
Just jumping in for a quick second to say I'm going to share a link in the chat for sessions at the OpenThePaths conference today. So there are some virtual sessions later on. If you have a little time after this, you are encouraged to check it out.
Thanks. Yeah, and again, big welcome to our OpenThePaths attendees who have called in and are attending the mini conference at University of Washington. Welcome. If you want to get involved, there's a couple of ways you can do that. You can always follow our GitHub page for any kinds of updates and announcements. And if you'd like to join our email list, please reach out to Cyrus to get on that. And all the links will be included, and we will send out all the materials after the meeting as well. I saw another hand up. Chad, go for it. We do not hear you, even though you are unmuted. Okay, yeah, feel free to type in the chat what you want to share with us. Thanks. Anyone else? All right. If you remember an announcement as we're going through here, feel free to put it in the chat and share with the community. And I'll turn it over to Cyrus for our next section.
Yeah, for those who don't know me, my name is Cyrus Chimento. I'm a fellow at the Bureau of Transportation Statistics. We've got a fairly short meeting today, and as Justyna said, we'll be talking a little bit about data representation categories and then breaking out into some discussion groups to talk about them. So I'm just going to do kind of a quick overview of the ways that bicycle, pedestrian, and physical accessibility infrastructure data are often represented. So I guess also, why is this important? So the purpose that we just adopted to advance the data that informs decision-making for individual travelers, government, private, nonprofit, and academic sectors through open data standards. In order to structure work on that purpose, we have to come to a decision ultimately of what form the baseline data that needs to be in order to inform that decision making. So I'm going to explain these broad categories of representation, show a few examples, and then, like I said, we'll break out into smaller groups to relate these categories to your experiences and needs and think about the group's direction. Before I dive into that, a few notes. The examples that we use here aren't meant to be comprehensive or have any value judgment attached to them in any way. We just pulled a few that we knew of to illustrate the different representations. And also that these are just broad groupings. So don't get too hung up on terminology, more just focus more on the examples, I guess. So first up is what we're calling one-dimensional data. So in this category, the actual location of the infrastructure is not mapped. So by that, I mean that there's no geospatial feature that describes the real-world location of a sidewalk or bike lane. Instead, the presence of the infrastructure and its characteristics are encoded in the attributes or attribute values of a different data set, like a roadway center line. So for examples, on the left, we have the Massachusetts DOT's pedestrian facilities data set, which is a roadway center line with attributes LT sidewalk and RT sidewalk, presumably denoting the presence of sidewalks on either side of the roadway, as well as a few other attributes that look like they might detail something about the sidewalk. Versus on the right is the District Department of Transportation's roadway subblock dataset, which is also a center line. And that has a number of attributes for the different types of bike facilities that might be present, and a value for the one that is present. For two-dimensional data, we've got a few different categories. So for disconnected linear features, the location, the exact location of the infrastructure is mapped. So that means that there is a linear geospatial feature that describes the real-world location of the infrastructure. But these linear features are not connected to one another, even if the infrastructure in the real world is connected or continuous. And there's also attribution attached to these linear features. Here we have an example from Minnesota DOT on the left, where the linear features represent bikeways on both sides of a street and have attached attributes for the facility type, width, surface type, and more. On the right is the City of Indianapolis's pedestrian network dataset, again with those linear features representing pedestrian infrastructure on both sides of the street, and attributes like width and condition. Another 2D category is the connected linear features category. So in this category, the location of the infrastructure is also mapped, but instead of disconnected linear features, it's represented by nodes connected by links to create a network. And there are attributes or tags attached to both the links and the nodes. An example on the left is from the University of Washington's Access Map application, which I'm sure many of you are familiar with. You can see that the sidewalks are continuously mapped on both sides of the street and connected to crossings with some of the basic sidewalk attributes displayed in the pop-up. And on the right, we have OpenStreetMap data showing something similar. So sidewalk links connected via nodes with attributes attached to both. Finally, for the 2D data, we have polygonal features. So here, the real-world location and area of the infrastructure is mapped, represented by individual polygon features with attributes attached to the polygons. On the left is Hawaii DOT's existing state crosswalks data. And apologies, I know it's hard to see, but this was the max zoom level on their data portal, where each crossing is represented by a polygon feature with attributes like type, providing more detail. And on the right, we have New York City with sidewalks mapped as polygons and relevant attributes like the status. And the final category is three-dimensional data. So by this, I mean a three-dimensional digital model of the infrastructure tied to GPS location. It's typical, but obviously not required, that geospatial features like points, lines, and polygons and their attributes are then derived from this 3D digital model. This image is from DeepWalk, and it's showing, I think, a LiDAR point cloud symbolized by depth and modeling a street corner with two curb ramps and the corresponding imagery on the right. So that's a quick overview of kind of how we're thinking about the different ways of representing these data that we're interested in. Yeah, I'll turn it over to Anat, if you want to expand on this overview at all, and then we can get into any questions or comments about this stuff.
Yeah, hi folks. So I'm super happy that we are starting to align on at least what are some possible classifications or ways we can map this kind of data. I think it's important for us to think along the lines of what makes the data usable for different use cases. So 3D data is probably the most informative, and there would be the greatest lossiness in converting it into the two-dimensional data. But can we use it out of the box for routing? Can we use it out of the box for determining accessibility in a neutral fashion using, computational ways? In the room here, we recently talked about the Open Trip Planner and how it is now being enhanced to adapt to accessibility in the public right-of-way and pedestrian ways, and which type of data would most accommodate that kind of build-out and innovation in accessibility and routing is one of the determinants that we might want to think about. The other things we want to probably talk and think about is how well can this data be stored? Is it easily storable? Is it easily taggable, and is metadata providing us the information we need? Are there tools out there to handle the data in ways such that we can join it with other data sets and join it with other attributes that people care about? We have folks from the CDC interested in joining data about pollutants, toxins, environmental factors. Which of these data classification or formats would be most possible to join the data in that way? So the tooling that's currently available, the storage of the data is important, and the ability to glean out metadata so that people can fairly well understand what's in here. And then finally, I think the ability to neutrally assess what the data contains with respect to different users of the environments, whether they be bike environments or the pedestrian ways, is also important. So the interpretability as well as the electability. Can somebody select, if somebody makes the election of curb ramps, is that something that they can elect in any one of these formats in a coherent way and be able to kind of digitally have that conversation with, say, a trip planner or a dashboard or some kind of planner interpretation of the public right-of-way. So that's all I was going to say, and thank you for the opportunity.
Yeah, thanks for framing the discussion. Before we move into the breakout rooms, does anybody have any questions or other comments about what we're talking about here? Then I'm going to hand it over to Jay to explain the breakout rooms.
Awesome. Can we also advance? Yep, there we go. The slide. There it is. Cool. Hi, everyone. I'm Jay Davis. I'm one of the folks from BTS who helps organize this group. If you haven't met me before, I'm just going to give you a quick spiel about breakout rooms. So we're going to go into smaller groups. There are going to be 5 groups in total. So there's going to be probably 8 to 9 people per group. We want to dig into these different data types and start thinking towards what it would look like to build a standard. So which of these data types would we want represented? And what are some of the things we need to consider along the way? So the breakout rooms are going to talk about how we would define the different types of data, what some of the drawbacks and benefits we see for each are, what some of the gaps might be. Think about priorities when it comes to building out a standard. Do we need to represent all of these? Are there certain ones that we want to focus on? Are there some that we want to encourage and others we want to discourage? Something to think about. And then we want to bring it back to use cases and how we expect that the data is actually going to be used. So we do have the use case inventory, which I think got put in the chat. We are not limited at all to those use cases. You're welcome to talk about and bring up any other use cases that you like. But that could be a good starting place if you're looking for a little inspiration. So Yeah, we are not going to do a debrief as a full group after the breakout rooms today. I know we usually do that, but this meeting today is only an hour long, so we don't have a whole lot of time for that. We are going to take notes in every single breakout room. We're going to compile and clean those notes, and we're going to keep bringing those back into these meetings. So nothing you say today is going to get lost. We're carrying it all forward. And it says we have 30 minutes for this chat, but I think we realistically have 20 something minutes. So I'm going to stop talking. And with that, let's go ahead and get the breakout rooms open.
It says they're being created as we speak.
Excellent. I'm also going to add really quickly, you'll have a facilitator in your breakout room. It will either be myself, Justyna, Cyrus, Jeff, or Anat. So look for us when you get in your room. Also a good thing to know, there is a note stock that we've created for all of the breakout rooms. So Cyrus has just helpfully posted that in the chat. So please go ahead and grab that link.
So the first question was, what are some use cases that folks in the room have for pedestrian access and bicycle data? And Kohei will be able to go around the room. All right, anyone interested in starting out the discussion on use cases? I see Doreen.
So, the Seattle Housing Authority just moved its central office, and I think the official address is 1101 Elliott Avenue West. So, this would be public housing residents, high use of public transportation, and the area is very weird. So when I put information into the trip planners, I get a couple of pieces back that are like, get off here, navigate around some corners, go down a steep hill. There's some other variations. And finally, I'm like, okay, I know which buses go on Elliott Avenue. So I'm just like, I know where to catch them. I know they go off really frequently. But that's a example of a lot of people need to use that stop. The transit issues are gnarly. So that's one example. I think I was talking earlier about people making decisions about retirement communities for aging relatives. In this case, it's a blind couple. Just to add extra, what else? That's enough. I talked about the crossing 4 lanes both directions. That's plenty. I want to hear from somebody else because I hope that I'm not the only one with these problems.
So go ahead and grab that. Just confirm that trip planner information seems uninformed, and we need to connect pedestrian access data with transit environments to provide better trip planning. Okay, great.
Okay, this is Thomas Craig speaking from WashDOT, and so I could prattle off some use cases, trip planning, accessibility analysis, inventorying of facilities, etc. But I guess I'll kind of cut through to part of this discussion that would be really educational for me. I am highly biased in the schema that we were just presented, which I thought was really useful, of 1D, 3 types of 2D, and 3D. I'm highly biased towards the 2-dimensional network-based type of model, because it seems to me to cover the important use cases that I'm aware of and that I've heard discussed in these conversations before around a connected graph for trip planning, but at the same time is not wildly storage intensive and complex to work with in some ways that the 3D data is. It's the just right, baby bear specification. So I would be really curious to basically hear, from folk in the room who have kind of specific arguments for the value of 1D representation or 3D representation, kind of on either side. I would just, encourage those who have thoughts on why 1D or 3D or a different type of 2D, the polygons, for example, would be really valuable to speak up about that, because I think that's maybe knowledge that some folk with my biases could learn from.
I love the silence because I share the bias.
This is John Campbell from Arcadis. Less a use case and more kind of a question or a thought. Within the 2D connected graph, how do we acknowledge that maybe there are competing priorities between use cases, and that the information that's most relevant when we're using the representation for asset management is maybe different than the priorities for routing purposes or vice versa? And maybe some of that is just helping it evolve slowly so that those are under consideration.
I want to give others the chance to speak, but I can address both of those, I guess. So I've been sitting on the Maryland DOT's effort to work on a unified sidewalks data set for the entire state. And a lot of deliberation happened, a lot of consideration of use cases, and in the end, they decided on 1D data. And really, it had to do with the amount of resources they have for the collection. So it's a lot more work to collect even linear data, much more so connected linear data. And they had limited resources to do that. Secondly, there was a concern around linear referencing, and the concern was that they'll never be able to do justice to linear referencing, so they may as well just abscond that whole problem by having the sidewalk annotations on top of the roadways. And what that meant is they recognized that this means that they necessarily will not collect any of the attributes that will be relevant to any of the use cases, John, that you just mentioned: asset management, any kind of routability. Well, that's not fair. So they will provide routability, but not really available with the neutral ability to assess whether accessibility is fully there for all types of access. And so that was the consideration. And of course, storage is a lot more limited for that tagged data information. One thing that I should be clear about is that the people managing that project are the same ones who are in charge of the OMOC data set, which is the one Maryland, one. OMOC doesn't. Yes, thank you. It's like one Maryland, one data. No, that doesn't work out. So they are the ones who fashioned the connected routable road network graph. And they are very much invested in maintaining that as being sort of the reference data set for Maryland. So, of course, the considerations there with the sidewalks was, are we going to do an entire new one centerline data set for sidewalks, or just provide the tagging on top of that roadway information that they had already collected? Did I answer the question? Not entirely. I think the second part of the question is, do we agree that we just need the routable graph to begin with? And then we can start talking about level 2, which is, for asset management, I really need to know who owns this, or I need to know who operated this last, or which license was provided in 1980 to put a driveway through here, versus other kinds of accessibility related information like surface and surface quality and things like that. I feel like we get too fast into those kinds of conversations where To Thomas's point, if we have the underlying graph, we can always add more data and more attributes and do that interchangeably. So I saw Elizabeth Saul, co-author of the mobility data interoperability principles. You know, the important part is that we can talk to each other and then we can add more attributes as needed. That's my standpoint.
Hi, Brian Jennings from Cambridge Systematics. I was just sitting here kind of thinking about all of this, and there were a couple things that I think came to mind, and I think you talked about how there were multiple users for this type of data, and I was thinking of some of the I'm aware of, and I know that curb space management is another thing that that is, you know, taking on similar efforts to map and track sidewalks and pathways and things like that that may be licensed and managed by cities to they're trying to be really thoughtful about that. Another thing that kind of came to mind is disruption management. And disruption management, when I think about it, I think about roadways, but there's also disruptions that happen on pathways and on sidewalks where maybe there's events going on, or streets are opened or streets are closed. Pathways may have gates that are only open during certain times. And I think that there's a use case to have the ability to have like overlapping, different types of data that can be, valid either for specific periods of time or at specific times of day, depending on how those spaces are used and managed. Yeah, I think those are the main things that I've been thinking about. That I think that there's use cases to try to handle that data. Oh, and I think the last one is variability, like where you have maybe roads that are open for like walking roads that maybe on weekends they're open, but then during weekdays that it's just the sidewalks. And how do you handle like kind of merging, merging that together to show that there's a larger open area versus other times when there's less area available for pedestrian or bike traffic.
So the question to the public is how to handle temporal data associated with different parts of the linear system. Again, I hate to be the talking one, but in AccessMap, when we started talking to stakeholders in the city of Seattle, and it was really clear that folks were using indoor infrastructure to traverse downtown because it's so hilly, and they have to enter at level 1 and go through the building, access the third level and exit to avoid an 11 to 14% grade on Seneca. And so what's become really clear to us is that we had to maintain that temporal information in some way. OpenStreetMap has temporal associations that are available for linear elements. And so that's what we were using earlier on with AccessMap to be able to address that question of like, oh, I'm traveling at 4:59 p.m. on Wednesday, so the building is still open, but as soon as it's like 5:01, it's not. And we had to be able to assess that. As we kind of grew our thinking about pedestrian environments, it became really clear that certain things were conditional. So if you had a certain friction value for a surface and it was raining or it was snowing, then you had to be able to put those two factoids together to be able to assess how traversable is this walkway and should we reroute through some other way. This is not presently implemented in AccessMap. We had a trial of that though, so it just took a long computational time, so it would have taken a hit on our users of AccessMap, but I do see it as a future direction to expand in. I think what's important to note is like basically things like crowdedness or noise. can have a temporal profile that's associated with every aspect of the road. It just becomes a question of how do you dynamically cost that in your routing algorithm, right? Like maintaining that data is great, and we have tons of sensors out there that are able to now collect that kind of data. The main question is what kind of hit do our users take when we try to incorporate way too much of that temporal information and potentially impact the operation of OTP, for example, as a consequence. I see Jeff raising his hand.
Yeah, I can't talk to the data modeling part, but from my own experience in using walking directions that the trip planner gives, a couple things. One, I think they're overly wordy. It's very confusing to try to use a walking direction output. It will, as an example, I routinely go to the Seattle Library from Kirkland, and the bus drops off at, I think, 5th and Marion, and it's a 1.5 block walk to library. The written instructions are a page long. Like walk 5 steps, turn right, walk on path, and you get to a corner and it never tells you you're crossing an intersection. It says go 30 feet forward and then take a left. I'm in a street with a light, cars around, and doesn't give me any of that information. So just the verbiage that comes out of whatever feed is getting given, I think that needs a lot of work. Thanks.
Are you speaking about a specific trip planner or wayfinder?
They seem to be the same because I'm assuming, like Thomas said, they're probably always using the same data set and maybe doing their own interpretation of it. But they never give me a street name that I'm walking on. I mean, I know Seattle pretty well, and I know that I'm walking down 5th, but it'll just say walk 50 feet with no reference to the street. And that's Google Maps, that's Find a Ride, that's other ones too. But again, I don't know what they're using.
Map? So the newest version of Access Map, and I hate to take over the meeting, but if Kunal can speak a little bit to that experience of the non-visual experience through a pedestrian way, that would be fantastic.
Hi everyone, I'm Kunal. So with Access Map, I think Jeff made a great point. A lot of applications don't really provide that kind of direction that you might need. So with Access Map, what we're trying to do is have information in a hierarchy, wherein the first level of information would probably be the similar direction that you might have to go 30 feet or whatever. The next level of hierarchy is the street name, and the third level of information is the granular information that you might find on the way while you're walking. So that could be a wastebasket, a bench that you might encounter, and totally hear the fact that it can be overwhelming. So what we are also trying to do with Access Map, and it's available. We would love feedback. What we're trying to do is also have the system or the app, or it's a web-based tool. So the tool give you alerts as to what's the next course of direction that you need to take. It could be, you're walking by a certain building, you're walking past a certain building, or you'll find a bench, or you need to make a left turn, right turn, whatever that could be. We're trying to make it more proactive so that the user doesn't have to really, the user might have a white cane, might have a guide dog with them. So much traffic, it can get overwhelming. So that's the idea, and it's available. So we would love feedback. It's not perfect as of now, but we'll get there.
Hi everyone, I'm Sam from the Taskar Center. So I feel like when it comes to the geometries and how to represent elements for pedestrians, I feel like sidewalks, we can look at them as a special case because typically sidewalks look the same. the rectangular shaped. So I feel like the center line linear representation of these entities makes a lot of sense for simplicity and capturing enough data about the connectivity of the graph and obstacles that come across the way. But as we're working on axis map and open sidewalks, some things become harder to represent in that, and I kind of want to challenge the only linear model. So things like last week's discussion, we talked about how parking lots could be really useful for a wheelchair user to get from one block to the other. It could literally save you 5 minutes rather than just using the sidewalk and going all around. So that kind of entities are harder to represent in a linear model. So I like to think of this solution as a hybrid between the linear and maybe some 2D polygons, which will add some complexity to the routing problem, but also from a user's perspective, it's a no-brainer. And it also reflects reality on the ground in a better way than simple lines. I don't know how accurately you can represent the parking lot with lines only for efficient routing. So yeah, that's my thought on the representation.
So is it fair to say that you are asking whether we ought to consider the additional complexity in routing that would be necessary when incorporating like polygon data into the 2D linear graph? Thank you. Any
so maybe I'll just add
OTP devs out there interested in taking him up on that challenge?
So I was going to throw something in support of that. I was sort of having a side conversation, but there's some bets to make on what technology is doing right now, and I think higher and higher fidelity imaging from LiDAR and satellite and on the ground stuff, and I don't know, crowdsourced GoPros or whatever else is clearly a trend, right? And so being able to, basically, I'm just voting for start trying to route with 2D and maybe even 3D raw imaging data sets as the source, as opposed to necessarily having to build consensus around an intermediate representation that is known to be lossy in various ways, build the debate about the assumptions that need to be made to agree on that representation, promote that standard, get everybody to implement that standard in different applications. That's a lot of work, and that's the people in the room are experts at doing that work. But I wonder if there's a way to kind of short circuit some of that by going directly from the raw sensed environment to non-trivial applications like routing, and tolerating some of the mistakes that some of these methods are going to make in the meantime. And so there, the other trend to bet on that I'll stop is what's going on with learning is a big deal, right? And so with learning is a big deal. So things that would have been sci-fi just a few years ago are starting to become kind of pretty routine in how people are building things. And it's not perfect, and as many people in the room I'm sure are aware, but it seems like it's a reasonable bet to try to make to not necessarily have to discretize everything, but rather find enough input-output examples and kind of learn that function rather than having to write it by hand and agree on it all. So I don't know, just maybe another vote for look at 2D and 3D representations.
So to bring the OTP perspective to support for polygon routings, for polygons in routing, from a technical perspective, that's there already. We can include polygons for open spaces as part of the pedestrian and wheelchair network. I think the bigger issue is that as soon as you're adding more complexity to your network, things that we all use as like rules of thumb for deciding whether to use a particular space for routing or not is a lot harder to abstract into a data model. And thinking about the example of like parking lots can be really great for access. They can, but they can also feel really uncomfortable and scary to people depending on the parking lot, the time of day, etc. And a lot of that is just kind of rules of thumb or instincts that people use to make their travel decisions on a given day, that trying to bake that into a routing algorithm for an itinerary we're going to give a user is a lot more complicated.
does one make elections about those kinds of aspects, right? So is it just about the tag? Is it don't route me through parking lots?
That's like the level of granularity we have right now, is we assume that everything is kind of out until proven good for the network.
Mm-hmm.
So if something is tagged as like a public plaza or a clear open space like that, then that's a polygon that we know is good.
Mm-hmm.
And so you kind of create that like whitelist or safe list of types of elements that you want to use. And leave a lot out.
Yeah, so I do come from an open trip planner, and kind of current state of practice wanting to deploy trip planner perspectives here, and kind of naturally have a little bit of the hesitancy around the potential downsides in terms of complexity from polygons and 3D modeling, but also clearly see the potential advantages and benefits of doing so. And I guess what I would say is I wonder how complex it would really be, or how whether it's perfectly kind of feasible to think in systems where we are collecting in 3D, storing raw in 3D, presenting and exporting 2D connected network graphs that can be efficiently and immediately utilized by a number of existing applications. And also exporting and servicing other use cases where 3D data is useful. So I guess I imagine, and maybe this is wrong, but I imagine that kind of from a implementation perspective, there's sort of like a 2D connected graph plus answer here that sort of is tries to make easy access to routability through a 2D connected network graph, but is deploys that in a system that is designed to maintain a database, or in some fashion prevent the loss that exists from kind of 3D collection and extraction, in order to support easing into those more advanced use cases over time. Yeah, I don't know if that's useful, but.
All right, so it sounds like the Transportation Data Equity Initiative needs to add in 3D data.
I mean, or maybe maybe it's about also incorporating into your 2D data 3D sources in a way where you've documented and maintained the viability of extrapolating a 3D model from that in the future. So I don't know. To me, it doesn't feel. It feels like we have a lot of work to do that is very productive with the 2D data, where we can serve a lot of use cases and improve user experiences very, very radically from that 2D data, and that's worth the effort. And the TDEI initiative focus on that is not misplaced, but may need to be aligned and evolve into 3D in the future.
Yeah, so actually the original proposal did include that, and then it turned out government stakeholders really don't like the security and privacy concerns that arise with actual images or video or LiDAR data. Not surprising, but at the same time, something to consider as far as like where some of the more technical innovations can go in this space, because I totally agree that there are ways to leverage that kind of information, not just for validation that, you know, the inferred network made sense and is correct, but also for additional purposes. Sorry, John, you were going to say something.
I guess, yeah, to follow up on what Thomas just said, I think at least in the OTP case and in a lot of routing platforms that use a network graph as the data model, a lot of the things that like we observe in the world as 3D can be still represented in a 2D graph, because it thinks of it. The only thing that a graph cares about is like the relationships between entities. So you've like your nodes or your connections in the graph. You have your links or your sidewalks or streets between those connections, and so you're able to model things that are actually in space on different levels or different heights. But the point that matters for routing is that the connections between them and the relationship between those. There's like this kind of in between that's a lot simpler or kind of condensed from a data perspective, but still gets that 3D quality for routing folks.
Do I hear a hidden bias at I don't want to deal with that 3D data, or is that not the concern?
At least right now, my perspective is like to get users of planners, whether it's Access Map or OTP or others, the information they need to navigate. That can be done with these relational graphs that aren't truly 3D, and that the kind of like value add for keeping that data modeled in full 3 dimensions isn't quite as clear, given how much more data intensive that is and potentially like computationally complicated it is. But that's also the bias of that's what I'm working with currently. So maybe there are a lot of good use cases we haven't thought of yet.
Well, I think we are out of time, and I do want to give our next panelists the opportunity to ambulate over here so you guys can get started. If there were some closing comments or things that people want to say, we can still do that. And I will call up the Disability Rights Washington, and specifically Amara and Tanisha, who are going to represent the report recently advanced by DRW and the Empower movement about the rider experience. Any closing comments? I saw some sort of hands, sort of kind of hands. Okay. Well, I think this was informative. I think, you know, just a few years ago, nobody would have even given any consideration to 3D data or sense data on a continuous collected basis. So we are entering a new era for sure. Thank you, everyone.
Possible we lost some folks along the way. Just looking at the number of participants we have back. Grace, is everybody back in the main room as far as you can tell?
It appears to be so.
Okay. Well, thank you again for joining us today. Our next full meeting will be on Thursday, May 30th at 3 p.m. Eastern. If you have any comments, suggestions, please feel free to email Cyrus or start an issue on GitHub. Jeff, do you want to say a couple closing remarks?
I just wanted to say thanks again for everybody's time. I hope the other breakout rooms had a great conversation like ours did, and we look forward to reviewing the notes.
Awesome. Thank you so much. And thanks again to folks from the OpenThePaths conference for joining us today. Take care, and we'll see you soon.